5, 4, 3, 2,
ये दे प्रज्वलन हुआ
1, 0.
Hi students, welcome to today's class. So in the previous video clips, so has been discussed about the concept fringe width. That means we derived an expression for fringe width. So now in this class, let us solve few of the numericals based on that fringe width formula. Now let us select the very first question for you. This question they asked in the year March 2015 for 5 mark. So now in Young's double slit experiment, the distance between the slits is 1 millimeter. Given the distance between the slits, so take it as that one as d is equals to 1 millimeter, and the fringe width is found to be 0.6 millimeter. Fringe width is found to be 0.6 millimeter. So given the fringe width, that is 0.6 mm. The fringe width is denoted by the letter beta. So that is beta is equals to 0.6 mm. When the screen is moved through a distance of 0.25 meter away from the slit, the fringe width becomes 0.75 mm. Find the wavelength of the light used. So that means here, if you consider here, this is the Young's double slit experiment, 2 slits. Here we have the screen. The distance between slit and screen is given. How much is given? So d value is equals to, the screen is moved through a distance away from the slit. Later I will explain about the distance here. Now the distance between these two slits here, this is the small letter d. So that we are going to observe the interference pattern. So now we are interference pattern observation martivi. So here this is the central maxima point. If the sources are moving towards the point P, this is the point P. The light sources are moving towards this point P. So now for the given data, is saying that, so what is the question for you means, in the Young's double experiment, the distance between the two slits, here the two slits distance is 1 millimeter. The fringe width is found to be 0.6 mm. So 1 distance, ಈ experiment ಈ slits distance, so 1 millimeter ಇದ್ದಾಗ, so ನಮಗೆ fringe width ಎಷ್ಟಿದೆ 0.6 mm ಇದೆ. So when the screen is moved through the distance of 0.25 meter away from the slit, ಈಗ ಏನು ಮಾಡ್ತಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಈ ಸ್ಕ್ರೀನ್ ಅನ್ನ ಸೊ ಇಲ್ಲಿಂದ ಮೂವ್ ಮಾಡ್ತಾರೆ ಅಂತ ಇನಿಷಿಯಲ್ ಇಲ್ಲಿಂದ, ಸೊ ಮತ್ತೆ ದೇ ಮೂವ್ ಟು ದಿ ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟು, ಸೊ 0.25 ಮೀಟರ್ ಇದು ಸ್ಕ್ರೀನನ್ನು ಇಲ್ಲಿ ತಗೊಂಬರ್ತಾರೆ. ದ ಚೇಂಜ್ ಇನ್ ಡಿಸ್ಟೆನ್ಸ್, ಈ ಡಿಸ್ಟೆನ್ಸ್ ಇಲ್ಲಿಗೆ ಅಂದರೆ ಈ ಸ್ಕ್ರೀನ್ ಇಲ್ಲಿ ಮೂವ್ ಆಗುತ್ತೆ. ಸೊ ಆವಾಗ ದ ಚೇಂಜ್ ಇನ್ ಡಿಸ್ಟೆನ್ಸ್ ಲೆಟ್ ಅಸ್ ಟೇಕ್ ದಟ್ ಇಸ್ ಫೈನಲ್ ಡಿಸ್ಟೆನ್ಸ್ d2. ಸೊ ಹೌ ಮಚ್ ಮೂವ್ ಮಾಡೋದವರು ಅಂದರೆ ಎಷ್ಟು ಮೂವ್ ಮಾಡ್ತಾರೆ ಇಲ್ಲಿ, ಸೊ 0.25 ಮೀಟರ್ನ ಹಿಂದಕ್ಕೆ ಹಾಕ್ತಾರೆ. ಸೊ ಆವಾಗ ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಎಷ್ಟಿರುತ್ತೆ 0.75 mm, ಅಂದರೆ ಈ ಸ್ಕ್ರೀನ್ ಮೇಲೆ ಫಾರ್ಮೇಷನ್ ಆಗಿರೋ ಫ್ರಿಂಜ್ ವಿಡ್ತ್ 0.75 mm ಇದೆ. ಹಾಗಾದ್ರೆ ಫೈಂಡ್ ದ ವೇವ್ ಲೆಂತ್ ಆಫ್ ದಿ ಲೈಟ್ ಯೂಸ್ಡ್. ಸೊ ವೇವ್ ಲೆಂತ್ ಆಫ್ ದಿ ಲೈಟ್ ಯೂಸ್ ಮಾಡಿರೋದು ಯಾವುದು, ಈ ಸೋರ್ಸಿಂದ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಿರೋ ವೇವ್ ಲೆಂತ್ ಆಫ್ ದಿ ಲೈಟ್ ಯಾವುದು ಅಂತ, ಅದರ ಸ್ಲಿಟ್ ಮುಖಾಂತರ ಬಂದಿರೋಂತಹ ಲೈಟು ಎಷ್ಟಿದೆ ವೇವ್ ಲೆಂತ್ ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗಿದೆ. ಸೊ ಫಾರ್ ದಟ್ ಪರ್ಪಸ್ ಲೆಟ್ ಅಸ್ ಟೇಕ್ ಹಿಯರ್ ದ ಇನಿಷಿಯಲ್ ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಬೀಟಾ 1 is equals to 0.6 mm, ಆ್ಯಂಡ್ ಸೊ ಬೈ ಅಂದರೆ ಈ ಡಿಸ್ಟೆನ್ಸ್ ಸ್ಕ್ರೀನ್ ಡಿಸ್ಟೆನ್ಸ್ ಮೂವ್ ಮಾಡಿದಾಗ, ಸೊ ಸೆಕೆಂಡ್ ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಅಂತ ಹೇಳಿದ್ರೆ ಎಷ್ಟಿದೆ ಅದು 0.75 mm. ಸೊ ನಾವು ಇನಿಷಿಯಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಕೊಟ್ಟಿಲ್ಲ ಅವರು, ಲೆಟ್ ಅಸ್ ಟೇಕ್ ಇನಿಷಿಯಲ್ ಡಿಸ್ಟೆನ್ಸ್ d1 ಆಸ್ d1 ಓನ್ಲಿ, ಆ್ಯಂಡ್ d2 ಫೈನಲ್ ಡಿಸ್ಟೆನ್ಸ್. ಇದನ್ನು ಮೂವ್ ಮಾಡ್ತಾರೆ, ಎಷ್ಟು ಮೂವ್ ಮಾಡ್ತಾರೆ 0.25 ಮೀಟರ್. ಇದು ಇನಿಷಿಯಲ್ d1 ಡಿಸ್ಟೆನ್ಸ್ ಆದರೆ ಇಲ್ಲಿಂದ ಎಷ್ಟು ಮೂವ್ ಮಾಡ್ತಾರೆ 0.25. ಸೊ ಹಾಗಾಗಿ ಇದನ್ನು ಮಾಡ್ತೀನಿ d2 is equals to d1 ಪ್ಲಸ್ 0.25 ಮೀಟರ್, ಅಂದರೆ ಇಲ್ಲಿಂದ ಸೊ ಮುಂದಕ್ಕೆ ಮೂವ್ ಮಾಡಿರೋಂಥದ್ದು d1 plus 0.25 meter. This is the given data for it. So based on that we need to find so wavelength of the light used. ಈಗ ನಾವು ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು, wavelength of the light ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. Now to calculate the wavelength of the light means the fringe width expression beta is equals to lambda d divided by d. This is the formula we have. Here our intention is to calculate this wavelength lambda, but he given beta 1 beta 2, the distance d1 and d2, and the distance between the two slits here, this distance is constant throughout the experiment. Remember that always the distance ಏನಾಗಿರುತ್ತೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ. ನಮ್ಮ PUC ಎಕ್ಸಾಮಿನೇಷನ್ ಬರುವಂಥ ಮಾಡಲ್ಸಲ್ಲಿ. ಸೊ ನಾವು ಟು ಫೈಂಡ್ ಔಟ್ ದಿಸ್ ಲ್ಯಾಂಬ್ಡಾ ಲೆಟ್ ಅಸ್ ಗೋ ಫಾರ್. ಸೊ ಲ್ಯಾಂಬ್ಡಾ ನಮಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಪ್ಪ ಅಂದರೆ ವಿ ನೀಡೆಡ್ ಫ್ರಿಂಜ್ ವಿಡ್ತ್, the initial distance and distance between the two slit. But here we don't know what is the d1 distance. d1 distance ನಮಗೆ ಗೊತ್ತಿಲ್ಲ. ಸೊ ಹಾಗಾಗಿ now let me find the first, the initial distance between the slit and the screen. To find out the initial distance, here in the first case you take it as beta 1 fringe width, so lambda d1 divided by d. So beta 1 fringe width ಇದ್ದಾಗ so distance d1 ಆಗಿರುತ್ತೆ. ಅದೇ ಥರ ಸೆಕೆಂಡ್ ಕೇಸಲ್ಲಿ ಸೊ beta 2 is equals to, so wavelength lambda, so d2 divided by d. Here wavelength of the light is same for the both the cases. ಸೊ ಸ್ಕ್ರೀನ್ ಇದ್ದಾಗ ಅಥವಾ ಸ್ಕ್ರೀನ್ ಮತ್ತೆ ಮುಂದಕ್ಕೆ ಹೋದಾಗ ವೇವ್ಲೆಂತ್ ಆಫ್ ದ ಲೈಟ್ ಸೇಮ್ ಇರುತ್ತೆ. ಆ ವೇವ್ಲೆಂತ್ ಆಫ್ ದ ಲೈಟ್ ನಾವು ಇಲ್ಲಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿರಬೇಕು. ಬಟ್ ಡಿಸ್ಟೆನ್ಸ್ d1 ವೇರಿ ಆದಂಗೆ, ಸ್ಕ್ರೀನ್ ಡಿಸ್ಟೆನ್ಸ್ ವೇರಿ ಆದಂಗೆ ಏನಾಗುತ್ತೆ, ಈ ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಅಂದರೆ ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಬೀಟಾ ಆ್ಯಂಡ್ ಬೀಟಾ ಟು ವ್ಯಾಲ್ಯೂಸ್ ಆಗ್ತಾ ಬರುತ್ತೆ. ಸೊ ಚೇಂಜಸ್ ಆಗ್ತಾ ಬರುತ್ತೆ. ಸೊ ನಾವು ಹಿಯರ್ ಟು ಫೈಂಡ್ ಔಟ್ ದ d1 ಡಿಸ್ಟೆನ್ಸ್, ಸೊ ನಾವು ಲೆಟ್ ಅಸ್ ಕಾಲ್ ದಿಸ್ ಇಸ್ ದ ಈಕ್ವೇಷನ್ ನಂಬರ್ 1 and here this is the equation number 2. So now if you go for, so beta 1 by beta 2, ಈಗ beta 1 by beta 2 ಮಾಡಿದ್ರೆ, so now what is the answer we are going to get? It means so beta 1 by beta 2, beta 1 divided by beta 2, which is equals to, so lambda d1 by d, so lambda d1 divided by d, this equation, so this one becomes now d divided by lambda, so d2. So now here this d get cancelled. d2 means this d2 is equals to d1 plus 0.25. ಈ d2 ಏನಂತ ಬರೀಬೋದು ನಾನು, ಸೊ d1 plus 0.25 ಅಂತ ಬರೀಬೋದು. Okay, so now this expression can be written as here lambda get cancelled, so remaining we have beta 1 by beta 2 in terms of distance. So look at here, distance d ಅಂದರೆ here the distance between slit and screen d1 divided by, so d1 plus 0.25, that is equals to d2 ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಸೊ d1 0.25 ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿರೋಂಥದ್ದು. ಸೊ ನಾವು beta 1 means we have 0.6 mm, that is 0.6 into 10 to the power of minus 3 divided by beta 2 0.75 mm, that is 0.75 into 10 to the power of minus 3, convert into a meter, the given in terms of millimeter the values. So now, so this one can be written as d1 divided by, so d1 plus 0.2. So now this expression is supposed to simplify that here. So 0.6 divided by 0.75. 0.6 divided by 0.75 means the answer we are going to get it at 0.8. So here 10 power minus 3 get cancelled. So 0.8 cross multiply ಮಾಡಿದ್ರೆ d1 plus 0.25, which is equals to, so d1. Again, so 0.8 into d1, 0.8 into 0.25 multiply ಮಾಡಿ. So thereafter 0.8 d1 ನ ರೈಟ್ ಹ್ಯಾಂಡ್ ತಗೊಂಡ್ಬಂದ್ರೆ, so then we have the 0.25 is equals to, so 0.25, or if you want you can proceed with the step by step. So 0.8 d1, so 0.25 into 0.8, here we have 0.8 d1 plus 0.25 into 0.8, 0.25 into 0.8 means 25 that is almost around we are going to get it 0.2, so which is equals to, so d1, or 0.2 is equals to d1 minus of 0.8 d1. So here d1 is the common, so d1 is the common, remaining 1 minus 0.8 we have, or so 0.2 is equals to d1 into, so 1 minus 0.8 means we have 0.2, d1 distance becomes 1 meter. So now we find the d1 distance. After finding this d1 distance, let us calculate the wavelength lambda. So now to find this wavelength lambda, ಈಗ wavelength lambda ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೋಸ್ಕರ let us use the formula. So beta is equals to lambda d divided by d. Here the beta fringe width, the fringe width distance is given, the beta 1 is 6 mm, that is the given the fringe width. Once again you recall that what are the given 6 mm, the fringe width given, it is 6 mm, not 6, it is 0.6 mm, so that, so 0.6 into 10 to the power of minus 3, distance between the slit and screen in the initial case just now we calculated, so 1 meter, and distance between the two slits, that is constant, So distance between the two slits it is 1 millimeter. 1 into 10 to the power of minus 3 meter. So now we need to find out lambda. So now here to find out the lambda we have the formula. So beta d, or directly substitute the values, it is easy for you to simplify. So here beta means we have in the place of beta, this formula implies that beta is equals to 0.6 into 10 to the power of minus 3, which is equals to lambda. We need to find d value 1 meter divided by the distance between the two slits is 1 mm, 1 into 10 to the power of minus 3. So if you cross multiply this means then you are going to get it lambda. So 0.6 into 1 is 0.6. So 10 power minus 3 into 10 to the power of minus 3, we are going to get it 10 to the power of minus 6. So 0.6 into 10 to the power of minus 6 we have, or this lambda can be rated as, finally the answer we are going to express in terms of meter. So 0.6 into 10 to the power of minus 6 meter. This is the final answer, the B2. Yes, my dear students, here, so once again, you look at the numerical. So given in the Young's double slit experiment, the distance between the distance between the two slits is 1 mm. So initial distance they are not given d1, but at the time ಈ ಸ್ಕ್ರೀನ್ ಮೇಲೆ ಫಾರ್ಮೇಷನ್ ಆಗಿರೋಂಥ ಫ್ರಿಂಜಸ್ ಎಷ್ಟಿದೆ, 0.6 mm ಇದೆ ಫ್ರಿಂಜ್ ಬಿಡ್ತು. ಅದಾದ ನಂತರ ಇಲ್ಲಿಂದ ಸ್ಕ್ರೀನ್ ಮೂವ್ ಮಾಡ್ತಾರೆ, ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸಿಗೆ ಮೂವ್ ಮಾಡ್ತಾರೆ, 0.25 ಮೀಟರ್ ಫ್ರಮ್ ಇನಿಷಿಯಲ್ ಪೊಸಿಷನ್. ಆವಾಗ ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಎಷ್ಟಿರುತ್ತೆ, 0.75 mm ಇರುತ್ತೆ. So then what is the wavelength of the light used in this case? So now to calculate the wavelength of the light used, we have this formula. So here we need to find out the wavelength means we require the distance between the slit and screen in the initial case. So for that purpose here, so we calculated the d1. Okay, so beta 1 beta 2 value ತಗೊಂಡು ಬಿಟ್ಟು, so ಎರಡು divide ಮಾಡಿದ್ರೆ then we are going to get it d1. So thereafter by substituting this d1 value in this formula, we are going to get it that wavelength of the light used. So in this case, so that one we got 0.6 into 10 to the power of minus 6 meter. Okay, so this is all about what the first numerical. ಈ numerical ಅನ್ನು so March 2015 ಅಲ್ಲಿ ಕೇಳಿರೋಂಥದ್ದು for 5 mark. Now let us go to the second one. The second numerical is in a Young's double slit experiment. So read the numerical. In a Young's double slit experiment, fringes of certain width are produced on the screen, kept at a certain distance from the slits. When the screen is moved away from the slits is 0.1 meter fringe width increases. That means when the slit is moved away from the slits, that means when the screen is moved away from the slits by 0.1 meter, fringe width increases by 6 into 10 to the power of minus 5 meter. The separation between the slit is 1 millimeter. Calculate the wavelength of light used. So for that also once again you go through the diagram here. Here the distance between the two slits we have, and here we have the screen. This is the distance between the two slits and the screen, capital letter D. So distance between these two slits is small letter d. So now he is saying that a certain width, fringes of certain width are produced on the screen, kept at a distance from the slits. When the screen is moved away from the slits, once again here this is the same motion. The screen is moving. Initially you take the d1, the change in the position of the screen you take it as d2. ಈಗ ಏನಾಗುತ್ತೆ, ಸ್ಕ್ರೀನ್ ಪೊಸಿಷನ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಸೊ d1 ಇಂದ d2 ಶಿಫ್ಟ್ ಆಗುತ್ತೆ. ಸೊ when it is shifted from d1 to d2, the fringe width increases. How much increases? It is 6 into 10 to the power of minus 5 meter. ಇಲ್ಲಿ fringe width ಮತ್ತೆ ಏನಾಗುತ್ತೆ, increase ಆಗ್ತಾ ಬರುತ್ತೆ. The separation between the slits is 1 millimeter. Okay, so write the given data. Distance between the two slits is 1 millimeter. Here this distance is 1 millimeter. When the screen is moved away from the slit is 0.1 meter fringe width increases. ಅಂತ ಹೇಳಿದ್ರೆ when the screen is moved away from the slit, 0.1 meter fringe width increases. Here fringe width increases. So how much fringe width increases means here is saying 6 into 10 to the power of minus 5 meter. But you're not given about the initial fringe width. You take it as initial fringe width beta 1 as beta 1, but the final fringe width it is so increases. So first fringe width beta 1 ಆದರೆ change in fringe width, we take it as 6 into 10 to the power of minus 5 meter. This is the change in fringe width, beta 1 and beta 2. The initial distance not given, you take it as d1, but the final distance, it is moved from initial position to final position. How much it is moved means 0.1 meter. So now this one can break it as d1 plus 0.1 meter. This is all about what? The given data. So that here once again we need to calculate the wavelength of the light used. Yes, my dear students, once again this is this model is similar to our previous model. So little bit changes. So what is the changes means? Here they are not given the initial fringe, but in the previous case they given the initial fringe width. But here is saying the initial fringe width as beta 1. So now to calculate the that distance, that wavelength of the light used, so write the formula. So required formula, it is we have the fringe width formula, so beta is equals to lambda d divided by d. ಸೊ ನಿಮ್ಮ ಪಿ ಯು ಸಿ ಎಕ್ಸಾಮಿನೇಷನಲ್ಲಿ ಕೊಟ್ಟಿರೋ ಪ್ರಾಬ್ಲಮ್ಸನ್ನು ಓದಿ, ಸೊ ಡಾಟಾ ಕರೆಕ್ಟಾಗಿ ಬರ್ಕೊಂಡು, ಸೊ ರಿಕ್ವೈರ್ಡ್ ಫಾರ್ಮುಲಾ ಬರೆದ್ರೆ, ಸೊ ಡೆಫಿನೆಟ್ಲಿ ವಿಲ್ ಗೆಟ್ ಇಟ್. ಸೊ ಮಿನಿಮಮ್ 1 ಮಾರ್ಕ್ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ಕೊಟ್ಟಿರೋ ಡಾಟಾನೆಲ್ಲ ಎಸ್ ಸಿಸ್ಟಮಲ್ಲಿ ಬರೆದು ಅದನ್ನು ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅದಕ್ಕೆ ರಿಲೆವೆಂಟ್ ಫಾರ್ಮುಲಾ ಇದ್ದರೆ ಸೊ ನಿಮಗೆ 1 ಮಾರ್ಕ್ ಇರುತ್ತೆ. ಸೊ ಕೆಲವೊಬ್ರು ಡಾಟಾ ಕರೆಕ್ಟಾಗಿದ್ದರೆ ಸೊ ಪ್ಲಸ್ 1 ಮಾರ್ಕ್ ಕೂಡ ಆ್ಯಡ್ ಮಾಡೋ ಚಾನ್ಸಸ್ ಇರುವಂಥದ್ದು. ಸೊ ಫಸ್ಟ್ ನೀವು ಈ ಕೆಲಸ ಮಾಡಬೇಕು. ಫಿಸಿಕ್ಸಲ್ಲಿ ಯಾವುದೇ ನ್ಯೂಮ್ಯಾರಿಕಲ್ ಇರಲಿ, ಸೊ ಪ್ರಾಬ್ಲಮ್ಸನ್ನು ಓದಿ ಅದಾದ ನಂತರ ಕೊಟ್ಟಿರೋ ಡಾಟಾನೆಲ್ಲ ಬರ್ಕೊಂಡು ಯು ಕನ್ವರ್ಟ್ ಆಲ್ ದಿ ಗಿವೆನ್ ಡಾಟಾ ಇಂಟು ಎಸ್ ಐ ಸಿಸ್ಟಮ್. ದೇರ್ ಆಫ್ಟರ್ ಗೋ ಫಾರ್ ದ ರಿಲೆವೆಂಟ್ ಫಾರ್ಮುಲಾ ಬೇಸ್ಡ್ ಆನ್ ದಿ ಗಿವೆನ್ ಡಾಟಾ. So now to calculate here the wavelength of the light used, the first fringe width beta 1 can be rated as, write the formula, beta 1 can be rated as so lambda d1 divided by d, and second one here the beta 2, the fringe width, the change in fringe width, that can be rated as lambda, so lambda d2 divided by d. Now if you want to find out here, so our intention is to find out the wavelength of the light used. So that is the reason why here if you call this is the equation number 1 and here this is the equation number 2. So our intention is to find out the wavelength of the light used. So in this case ಈ beta 1 beta 2 ಗೆ wavelength of the light used ಸೇಮ್ ಇದೆ. ಸೊ ಹಾಗಾಗಿ in the both the formula lambda is constant. So now the equation number 2 implies that. So now I am going to substitute the given data into equation number 2. Why? Because we don't know what is the beta 1. Beta 1 value ನಮಗೆ ಗೊತ್ತಿಲ್ಲ, so d1 value ಕೂಡ ಗೊತ್ತಿಲ್ಲ. ಸೊ ಹಾಗಾಗಿ ಸೊ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಎಕ್ಸ್ಪ್ರೆಸ್ ದಿಸ್ ಬೀಟಾ 1 ಲ್ಯಾಂಬ್ಡಾ 1 ಅಂದರೆ ಈ ವ್ಯಾಲ್ಯೂಸನ್ನಲ್ಲಿ ಏನು ಮಾಡ್ತೀನಿ, ಈ ಬೀಟಾ 2 ಫಾರ್ಮುಲಾದಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀನಿ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಈಗ ಈ ಈಕ್ವೇಷನ್ ನಂಬರ್ 2ನ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡಿರೋದು. ಈ ಈಕ್ವೇಷನ್ ನಂಬರ್ 2 ಅಲ್ಲಿ ಸೊ ನಾವು ಬೀಟಾ 2 ಅಂತ ಹೇಳಿದ್ರೆ ದಿಸ್ ಬೀಟಾ 2 ಕ್ಯಾನ್ ಬಿ ರೈಟೆಡ್ ಆಸ್ ಬೀಟಾ 1 ಪ್ಲಸ್ 6 ಇಂಟು 10 to the power of minus 5 meter, which is equals to wavelength of the light is used common, remaining d2. So d2 distance means we are going to express that is in terms of d1, that is d1 plus 0.1 meter divided by the distance between the two slits is 1 millimeter, that is 1 into 10 to the power of minus 3 meter. So this is all about what the given data. Or here this d later we are going to substitute, ಯಾಕಂದರೆ ಈ lambda d1 plus 0.1 ಇದೆ. ಸೊ ನಿಮಗೆ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಈಸಿ ಆಗಬೇಕಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ ಸೊ ಲೇಟರ್ ವಿ ವಿಲ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ದ ವ್ಯಾಲ್ಯೂ. ಸೊ ಫಸ್ಟ್ ಯು ಸಿಂಪ್ಲಿಫೈ ದಿಸ್ ಒನ್ ಇಯರ್. ಸೊ ಬೀಟಾ 1 plus 6 into 10 to the power of minus 5, we have that answer. And here before that beta 1, look at here, beta 1 can be rated as lambda, so d1 divided by d. By using equation number 1, in the place of beta 1 I am going to substitute this value. So plus 6 into 10 to the power of minus 5, which is equals to lambda, so d1 plus 0.1 divided by the distance between the two slits. So here now if you split up this equation here, lambda d1, lambda, so d1 divided by d plus 6 into 10 to the power of minus 5. Go for the modification in the right hand side, and that is lambda d1 divided by d, so plus 0.1 lambda divided by the distance between the two slits, that is small letter d. So look at it, now this lambda d1, so if lambda d1 by d left hand side bandre, so minus lambda d1 by d agutte. So hagagi these two are get cancelled. So remaining we have so 6 into 10 to the power of minus 5, which is equals to 0.1 lambda divided by d. So now we can substitute that d value. This d value is equals to how much? That this d value is equals to, so now you can substitute that value here, otherwise here only you can substitute it. So d value, this value is equals to how much? He's saying 1 millimeter. So look at that, d value is 1 millimeter. So 1 into 10 to the power of minus 3. So that here this one becomes, so 6 into 10 to the power of minus 3 and minus 5. So 10 to the power of minus 8. 6 into 10 to the power of minus 8 divided by 0.1. So that it becomes 6 into 10 to the power of minus 8, or go for step by step. Why to confuse here? 6 into 10 to the power of minus 5, which is equals to 0.1 multiplied by lambda divided by the distance between the two slits, that is 1 into 10 to the power of minus 3. Here this lambda can be rated as, so now this lambda can be rated as 6 into 10 to the power of minus 3 into minus 5 minus 8. 6 1 is 6, remaining it is 0.1 multiplied by lambda, means lambda value it becomes a 0.1. That means that can be rated as 1 into 10 to the power of minus 1, this 0.1. So lambda we have 6 by 1 means answer the 6. So 10 to the power of minus 8 divided by 10 to the power of minus 1. So 10 to the power of minus 8 divided by 10 to the power of minus 1 means we have 6 into 10 to the power of minus 7. Or this can be rated as, so lambda is equals to 60 into 10 to the power of minus 8 meter. This is the wavelength of the light used in this given numerical. This is also similar version. Yes, my dear students, here. So once again, listen to me. I will repeat this model. In a Young's double slit experiment, fringes of certain width are produced on the screen, kept at a distance from the slits. When the screen is moved away from the slit ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ಈಗೇನು ಮಾಡ್ತಾರೆ, ಫಸ್ಟಿಗೆ ಇನಿಷಿಯಲ್ ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಗೊತ್ತಿಲ್ಲ, ಇನಿಷಿಯಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಕೂಡ ಕೊಟ್ಟಿಲ್ಲ ಅವರು, ಬಟ್ ದಿ ಗಿವೆನ್ ದ ಚೇಂಜ್ ಇನ್ ದ ಫೈನಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಆ್ಯಂಡ್ ಫೈನಲ್ ಫ್ರಿಂಜ್ ವಿಡ್ತ್. ಸೊ ಹಾಗಾಗಿ ಫೈನಲ್ ಡಿಸ್ಟೆನ್ಸನ್ನು ವಿ ಎಕ್ಸ್ಪ್ರೆಸ್ಡ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಇನಿಷಿಯಲ್ ಡಿಸ್ಟೆನ್ಸ್ d1 plus 0.1 and final fringe width b2 is equals to beta 1 plus 6 into 10 to the power of minus 5 meter. So thereafter we find that distance, which one it is means, so we are calculated the distance, means what we are calculated here means here beta is equals to lambda d divided by d, that means wavelength of the light we need to find. So that is the reason why we have selected this equation number 2. In the equation number 2 we have substituted the equation 1. ಅಂದರೆ equation 1 values ಅನ್ನು ಈ 2 substitution ಮಾಡಿದ್ದೀವಿ. ಯಾಕೆಂತ ಹೇಳಿದ್ರೆ ಇದು unknown values ಮತ್ತು ಇದು unknown values ಆಗುತ್ತೆ. ಎರಡು unknown values ಆದರೆ so we cannot find the known values. That is the reason why it becomes somewhat complicated. ಅದಕ್ಕೋಸ್ಕರ beta 1 ಅನ್ನು beta 2 substitution ಮಾಡ್ಕೊಂಡು, so then we simplified and we find that the lambda value we calculated 60 into 10 to the power of minus 8 meter. Yes, my dear students, now let us move to the second version. Second version completed. Now the third model. So in Young's double slit experiment, while using a source of monochromatic light, that means using source of light of wavelength of light is saying, wavelength of light is, we take it as 4500 angstrom. Wavelength of the light is 4500 angstrom. The fringe width is 5 mm. Beta 1 is 5 mm. If the distance between the screen and the plane of the slit is reduced to half, look at here. So this fellow is saying the distance between the slit and screen is reduced to half. Initial distance, if you take d1 as d means d1 as d1, you take it initial distance. The change in distance d2 is equals to, that is half of the initial distance, d1 divided by 2 as per the given data. So what should be the wavelength of the light used to get fringe width of 4 mm ಅಂತ ಹೇಳಿದ್ರೆ, so beta 2 is given, so beta 2 value is 4 mm. So here we need to find out wavelength of the light. That means for the given data, the relevant diagram if you draw means, so now this is the distance between the slit and screen. Here slits d and here we have the capital letter D. So now when we incident a wavelength of 4500 angstrom ಆಫ್ ಇನ್ಸಿಡೆಂಟ್ ವೇವ್ ಲೆಂತ್ನ ಅಂದರೆ ಇನ್ಸಿಡೆಂಟ್ ಲೈಟ್ನ ವೇವ್ ಲೆಂತು ಇಷ್ಟು 4500 ಆಂಗ್ಸ್ಟ್ರಾಮ್ ಆಗಿದ್ದರೆ, ಸೊ ನಮಗೆ ದ ಡಿಸ್ಟೆನ್ಸ್ ಇನಿಷಿಯಲ್ ಡಿಸ್ಟೆನ್ಸಲ್ಲಿ ಫ್ರಿಂಜ್ ಬಿಡ್ತು 5 ಮಿಲಿಮೀಟರ್ ಇತ್ತು. ಈಗ ಏನು ಮಾಡ್ತಿದ್ದೀನಿ, ಈ ಸ್ಕ್ರೀನ್ ಡಿಸ್ಟೆನ್ಸನ್ನು ರಿಡ್ಯೂಸ್ ಮಾಡ್ತಿದ್ದೀನಿ. ಹೌ ಮಚ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ರಿಡ್ಯೂಸ್ ಮೀನ್ಸ್ d/2. ಸೊ d2 is equals to d/2 ಆರ್ ಇನಿಷಿಯಲ್ ಡಿಸ್ಟೆನ್ಸ್ d1/2. ಅಂದರೆ ಇದನ್ನು ಈಗ ಆಫ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಸ್ಕ್ರೀನ್. ಈಗ ಈ ಸ್ಕ್ರೀನ್ ಇಲ್ಲಿರೋದು ಏನಾಯ್ತು, ಈಗ ಆಫ್ ಆಯ್ತು. ನಾವು ವೇರ್ ಈಸ್ ದ ಇಂಟರ್ಫರೆನ್ಸ್ ಪ್ಯಾಟ್ರನ್. ಈ ಕೇಸಲ್ಲಿ ಏನಾಯಿತು, ಈಗ ಇಂಟರ್ಫರೆನ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ ಈಗ ಈ ಕೇಸಲ್ಲಿ ಬೀಟಾ ಎಷ್ಟಾಯಿತು, ಸೊ 4 mm ಅಂದರೆ ಬೀಟಾ ವ್ಯಾಲ್ಯೂ ಏನಾಯಿತು, ರಿಡ್ಯೂಸ್ ಆಯಿತು. ಬೀಟಾ ವ್ಯಾಲ್ಯೂ ರಿಡ್ಯೂಸ್ ಆದಾಗ ಸೊ ವಾಟ್ ಈಸ್ ದ ವೇವ್ ಲೆಂತ್ ಆಫ್ ದಿ ಲೈಟ್, ಸೊ ಅದ್ರ ಮೇಲೆ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿರೋಂಥ ವೇವ್ ಲೆಂತ್ ಆಫ್ ದಿ ಲೈಟ್ ಟು ಗೆಟ್ ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಆಫ್ 4 mm. ಇಷ್ಟು ನಮಗೆ ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಬರಬೇಕು. ಸೊ ಅವಾಗ ಎಷ್ಟು ವೇವ್ ಲೆಂತ್ ಆಫ್ ಲೈಟ್ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ 4500 ಆಂಗ್ಸ್ಟ್ರಾಮ್ ಇದ್ದಾಗ ನನಗೆ ಎಷ್ಟು ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಫಾರ್ಮೇಷನ್ ಆಗಿತ್ತು, 5 ಮಿಲಿಮೀಟರ್ ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಫಾರ್ಮೇಷನ್ ಆಗಿತ್ತು ಈ ಡಿಸ್ಟೆನ್ಸಲ್ಲಿ. ಈಗ ಏನು ಮಾಡ್ತಿದ್ದೀನಿ, ಡಿಸ್ಟೆನ್ಸನ್ನು ಅದನ್ನು ರಿಡ್ಯೂಸ್ ಮಾಡ್ತಿದ್ದೀನಿ, ಆಫ್ ದ ಡಿಸ್ಟೆನ್ಸಿಗೆ ತೊಗೊಂಡ್ಬರ್ತೀನಿ. ಹಾಗಾದರೆ ಸೊ 4 mm ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಬರಬೇಕಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ ನಾನು ಎಷ್ಟು ವೇವ್ ಲೆಂತ್ ಆಫ್ ಲೈಟನ್ನು ಯೂಸ್ ಮಾಡಬೇಕು. ಸೊ 4500 ಆಂಗ್ಸ್ಟ್ರಾಮ್ಗೆ 5 mm ಫ್ರಿಂಜ್ ವಿಡ್ತು. ಹಾಗಾದರೆ 4 mm ಫ್ರಿಂಜ್ ವಿಡ್ತಿಗೆ ಎಷ್ಟು ವೇವ್ ಲೆಂತ್ ಆಫ್ ಲೈಟ್ ಬರುತ್ತೆ ಅನ್ನೋದು ನಾವು ಇಲ್ಲಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗಿರೋಂಥದ್ದು. So for that purpose, write the given data, thereafter the required formula, the standard formula, right? So our standard formula, that is beta formula. So beta is equals to lambda d divided by d. So here don't get confused, I can d and d. This small d is the distance between the two slits and capital letter D is the distance between the slits and observation screen. So now to calculate here, we need to find out, first we write beta 1. Why? Because he given the initial distance and final distance and initial fringe width and final fringe width. He is saying, so beta 1 is here, wavelength of the light is also here, changes. So it you take in terms of lambda 1. So initial distance between slit and screen is d1 divided by the distance between the two slits. Now the beta 2 can be rated as, so lambda 2, that's we need to find out here, distance between the slits and screen you take it as d2 divided by distance between the two slits. So now here we have the two ratios, ಅಂದರೆ beta 1 and beta 2 ಗೊತ್ತಿದೆ. ಇದರಲ್ಲಿ ನಾವೇನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು, lambda 2 ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. So that is the reason why I am going to take the ratio of these two equations. So now if we go for the ratio means, so this can be rated as, so beta 1 divided by beta 2. ಯಾಕೆ ರೇಷಿಯೋ ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಎರಡು ವ್ಯಾಲ್ಯೂಸಲ್ಲಿ ನಾವು ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು, lambda 2 ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಸೊ ಹಾಗಾಗಿ ಈ lambda 2 ಫೈಂಡ್ ಔಟ್ ಮಾಡಲಿಕ್ಕೋಸ್ಕರ, so here the given values is, so lambda 1 given, d1 distance is saying initial distance d1 only and final distance is reduced to half of that, d1 here, d1 and d2 known values. Lambda 1 is a known value, distance between the two slit is known value, but so lambda 2 we don't know. That is the reason why to calculate this lambda 2 we are going to take the ratio of these two equations. So that is beta 1 by beta 2. This can be rated as lambda 1 d1 divided by d multiplied and divided by whole divided by multiplied. So this expression becomes now lambda 2 d2. The whole divided multiplied. So this equation modified to this form. So now look at the cancellation term. So d1 get cancelled. So remaining beta 1 divided by beta 2, which is equals to, so lambda 1 d1 divided by lambda 2. This d2 can be rated as, look at here, d2 is equals to, so d1 divided by 2 as per the given data. ಕೊಟ್ಟಿರೋ ಡಾಟಾ ಪ್ರಕಾರ, so d2 is equals to d1 by 2. So ಹಾಗಾಗಿ, so now this d2 I am going to write it as d1 by 2. So d1 divided by 2. This d1 get cancelled. So remaining we have the fringe width expression beta 1, ratio of the fringe width beta 1 by beta 2 is equals to 2 lambda. This 2 goes to the numerator. So 2 lambda 1 divided by, so lambda 2. So lambda 1 given, beta 1 beta 2 values are given. So based on that we need to find the lambda 2 values. So here, so beta 1 by beta 2, right, beta 1 by beta 2 is equals to 2 lambda 1 divided by lambda 2. Right, the given values. So beta 1, the fringe width, how much is saying beta 1, 5 mm, the given value 5 millimeter, 5 into 10 to the power of minus 3 meter. So beta 2 4 millimeter, 4 into 10 to the power of minus 3 meter, which is equals to 2 into lambda incident wavelength light lambda, the first case 4500 angstrom. 4500 angstrom means 10 to the power of minus 10 meter. Angstrom to meter, 10 to the power of minus 10 meter, divided by, we need to find lambda 2. That is lambda 2. So now if you go for that, so 10 to the power of minus 3 get cancelled, meter get cancelled. So 5 divided by 4. The 5 divided by 4, which is equals to, so 4500 into 2, it becomes 45 to the 90. That means, so 9000 multiplied by 10 to the power of minus 10 divided by lambda 2. Or if you simplify these versions, means lambda 2 can be rated as, so 9 4s are 36, it becomes now 36,000 divided by 5. So that answer is equals to 7,200. So in terms of angstrom, that is 10 to the power of minus 10 meter. So this is the wavelength of the light used. So in the given case, yes, my dear students, once again I will repeat the numerical. Look at here, this is the question they asked in the year 2016, July 2016. Andre, so repeater papers keliranta problem idu. So first wavelength of the light 4500 angstrom iddaga, so screen ಮೇಲೆ ಫಾರ್ಮೇಷನ್ ಆಗಿರುತ್ತೆ ಫ್ರಿಂಜ್ ವಿಡ್ತ್ 5 ಮಿಲಿಮೀಟರ್ ಇರುತ್ತೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಏನು ಮಾಡ್ತಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಈ ಸ್ಕ್ರೀನನ್ನು ಇನಿಷಿಯಲ್ ಡಿಸ್ಟೆನ್ಸ್ಗಿಂತ ಅಂದರೆ ಈ ಸ್ಲಿಟ್ಟಿಂದ ಇನಿಷಿಯಲ್ ಡಿಸ್ಟೆನ್ಸಿಗೆ ಆಫ್ ಡಿಸ್ಟೆನ್ಸ್, ಅಂದರೆ ಇಲ್ಲಿಂದ ಇನಿಷಿಯಲ್ ಡಿಸ್ಟೆನ್ಸಿಂದ ಆಫ್ ಡಿಸ್ಟೆನ್ಸ್ ರಿಡ್ಯೂಸ್ ಮಾಡಿದ್ರೆ, ಸೊ ದೆನ್ ಫ್ರಿಂಜ್ ವಿಡ್ತ್ ಎಷ್ಟು ಫಾರ್ಮೇಷನ್ ಆಗಿರುತ್ತೆ, 4 ಮಿಲಿಮೀಟರ್. ಹಾಗಾದರೆ ಸೊ ವಾಟ್ ಈಸ್ ದ ವೇವ್ಲೆಂತ್ ಆಫ್ ದ ಲೈಟ್ ಈಸ್ ಯೂಸ್ಡ್ ಟು ಗೆಟ್ ದಿಸ್ ಬೀಟಾ ಆರ್ this beta 2 fringe width values. So now to calculate the wavelength of the light is used means you are going to express that beta 1 and beta 2 formula in terms of that is required formula lambda d divided by d ಆ ಫಾರ್ಮುಲಾ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಮಾಡಿ ಅವೆರಡು ಈಕ್ವೇಷನ್ಸ್ ಇಂದ ರೇಷಿಯೋ ತೆಗಿತೀವಿ. ಸೊ ದಟ್ ನಮಗೆ ನಂಬರ್ ಆಫ್ ಅನ್ನೋನ್ಸ್ ರಿಡ್ಯೂಸ್ ಆಗ್ತಾ ಬರ್ತವೆ. ಸೊ ರಿಮೈನಿಂಗ್ ವಿ ಹ್ಯಾವ್ ದಿಸ್ ಫಾರ್ಮುಲಾ. ಈ ಗಿವೆನ್ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಸೊ ನಾವು ಗಿವೆನ್ ವ್ಯಾಲ್ಯೂಸ್ ಅಂತ ಹೇಳಿದ್ರೆ ಇದು ಗಿವೆನ್ ಫಾರ್ಮುಲಾ ಅಲ್ಲ, ಇದು ನಾವು ಡೆರೈವ್ ಮಾಡ್ಕೊಂಡಿರೋ ಫಾರ್ಮುಲಾ. ಈ ಫಾರ್ಮುಲಾದಲ್ಲಿ ನಾವು ಕೊಟ್ಟಿರೋ ವ್ಯಾಲ್ಯೂಸ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದರೆ ಸೊ ದೆನ್ ವಿ ಹ್ಯಾವ್ ದಿಸ್ answer, that is 7200 into 10 to the power of minus 10 meter. Yes, now let us move to the, so the one more model, the similar version to this. As read the given numerical. The light of wavelength 6000 angstrom is used to obtain the interference fringes of width 6 mm in a Young's double slit experiment. Calculate the wavelength of light required to obtain fringe width of 4 mm when the distance between the screen and the slits is reduced to half of its initial values. Once again, this is also the our similar version. So previous ನಾವೇನು ಸಾಲ್ವ್ ಮಾಡಿದ್ವಲ್ಲ ಅದೇ ಥರ ಪ್ರಾಬ್ಲಮ್ಸು. ಸೊ ಇಲ್ಲಿ ನಾವು ಸಾಲ್ವ್ ಮಾಡೋಂಥದ್ದು. ಸೊ ಇಯರ್ right, light of wavelength of 6000 angstrom, light of wavelength of 6000 angstrom, lambda 1 is equals to 6000 angstrom. 6000 ಅಂದರೆ 6000 into 10 to the power of minus 10 meter. ಸೊ ಇಂಟರ್ಫರೆನ್ಸ್ ಫ್ರಿಂಜಸ್ ವಿಡ್ತ್ 6 mm. ಅವಾಗ ಇಂಟರ್ಫರೆನ್ಸ್ ಫ್ರಿಂಜಸ್ ವಿಡ್ತ್ ಎಷ್ಟಿದೆ, 6 mm. 6 into 10 to the power of minus 3 meter ಇದೆ. So now the wavelength of the light required to obtain fringe width 4 mm. ಹಾಗಾದರೆ ಸೊ beta 2 ಎಷ್ಟಿದೆ, 4 mm. 4 mm means 4 into 10 to the power of minus 3 meter. You convert into a SI system. So at the time what happens here, once again the screen distance is reduced to half of its initial value. So that if the beta 2 got 4 mm. Here what is the wavelength of the light used in this case? So this is also the similar version to the previous model. So like that here the required formula beta is equals to lambda d divided by d. ಅದೇ ಥರ ಇರೋಂಥ ಪ್ರಾಬ್ಲಮ್ಸು, ಸೇಮ್ ವರ್ಷನ್. Now this beta 1 can be rated as lambda 1, so d1 divided by d. Like that beta 2 can be rated as, this beta 2 can be rated as lambda d2 divided by d. And here now the initial distance, if we take it as d and the final distance as d by 2. So initial distance I will take d1 as d and d2 as d by 2 as per the given data. So now this expression becomes, if you go for beta 1 divided by beta 2, so now we have lambda 1 d1 divided by ಸೊ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಟೂ ಸ್ಟೇಟ್ಸ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ಓಲ್ ಡಿವೈಡೆಡ್ ಬೈ ಸೊ ಬೀಟಾ 2 ಅಂತ ಹೇಳಿದ್ರೆ ಇಟ್ ಬಿಕಮ್ಸ್ ನಾವು ಸೊ ಡಿ ಡಿವೈಡೆಡ್ ಬೈ ಸೊ ಲ್ಯಾಂಬ್ಡಾ 2 d/2. ಸೊ ನಾವು ದ ಕ್ಯಾನ್ಸಲೇಷನ್ ಟರ್ಮ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ ಸೊ D2 ಪ್ಲೇಸಲ್ಲಿ ನಾನೇನು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದರೆ d/2 ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದ್ದೀನಿ ಅಷ್ಟೇ ಇಲ್ಲಿ. ಸೊ ಡಿ ಗೆಟ್ ಕ್ಯಾನ್ಸಲ್. ದಿಸ್ ಇನಿಷಿಯಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಇಫ್ ಟೇಕ್ ಇಟ್ ಆಸ್ D1 ಅನ್ನು ಡಿ ಅಂತ ತೊಗೊಳ್ತಾ ಇದ್ದರೆ ಸೊ D1 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಸೊ D2 is equals to D1 divided by 2. It becomes now D1. So D1 get cancelled. So remaining we have so beta 1 divided by beta 2 which is equals to so 2 lambda 1 divided by lambda 2. The beta 1 value is saying 6 into 10 to the power of minus 3 meter divided by beta 2 4 into 10 to the power of minus 3 meter. So 2 wavelength of the light used lambda 1 6000 into 10 to the power of minus 10 meter in terms of angstrom to SI unit divided by lambda 2. So now if you cross multiply this 6 by 4, so what is the answer we have? So 3 divided by 2. 3 divided by 2 means here we have 2 to the 4, 3 to the 2000. 2000 means 4 into 2 8000. So now this lambda 2 becomes 10 power minus 3 get cancelled. So 2 to the 4. So 3 1 the 3 2 the. So 4 into 2 8000. So 8000 into 10 to the power of minus 10. 8000 into 10 to the power of minus 10 meter. So this is the lambda 2 value. Yes, my dear students, this is all about what your the numericals in the, what I solved in this class. So next classes, so I will discuss about few of your competitive examination applications based on this Young's double slit experiment. And these numericals, please work out once again the given numericals so that upcoming your test, the weekend test, so you may expect one numerical so from this model. Okay, so based on this Young's double slit experiment ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವ ಮಾಡಲ್ ಅಂತ ಹೇಳಿದ್ರೆ Young's double slit experiment ಮೇಲೆ ಈ ಥರ ನೀವು ಒಂದು ಕ್ವಶನ್ಸನ್ನು ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ಬೋದು. Okay, so now it's enough my dear friends. Thank you. Have a good learning day.